Hello my dear students, this is Akash HD and welcome to the ASD Physics classes students. I hope so you all are doing really great. So students, in this video we are going to solve the questions from the Ohm's law and we are going to learn different methods like method of same potential, how to apply symmetry method, how to solve question based upon the infinite ladder. Okay, so all these things we are going to cover in this video. So let's start the video and let's learn all these concepts. So here you can see first equivalent resistivity in different cases. This is also one kind of question. First we will cover this. So kindly see here under the case 1, two metal wires of identical dimensions are connected in series if sigma 1 and sigma 2 are the conductivities of the metal wire respectively. The effective conductivity of the combination is how much? So here you have to remember that one thing. Here they are talking about the equivalent conductivity, and conductivity depends upon the nature of the material and temperature independent of the dimension. So what we will do that when we are going to calculate the equivalent, the dimension of the equivalent conductor will be similar to the given conductors. Here also I have taken here the two conductors. Okay, so I can write here first I will solve in terms of resistivity, later I will convert into conductivity. So let's see here. Here we can write here, let's take here this resistivity is the rho 1, conductivity sigma 1. Here resistivity rho 2, conductivity sigma 2. Now, and here this length of the first conductor is L and the length of the second conductor is also L, because they told here identical dimensions. Okay, and let's take here the area of cross section is A, and anyhow for this also area of cross section A. So if we see this conductor overall, we can tell the total length is 2L and area of cross section A, is it? So when we are going to draw here the equivalent, what is this? We are going to get here the equivalent. So students, what will happen that here in this equivalent conductor, the length will be same. Here length how much? 2L. So here also remember that here this length will be 2L. Okay, and area of cross section how much here? The area of cross section will be A. Okay, and here the equivalent resistivity how much I have taken here? Rho equivalent. So remember that here the dimension of the equivalent conductor will be similar to the given conductors. Okay, then after that what we'll do here? We will apply here the normal formula. So what is the normal formula here students? Here as R equivalent is equal to R1 plus R2. Is it? Now what is the R1? R1 is given by rho 1 into L by A. Similarly, rho 2 into L by A. And what is the R equivalent? Can you see from here? It is given by rho equivalent into 2L by A. Remember that 2L by A. So after that when you will simplify this both the sides, L by A will cancel out. So you can write here 2 into rho equivalent is equal to rho 1 plus rho 2. Is it? Or we can write here this rho equivalent is equal to rho 1 plus rho 2 by 2. Okay, this is the main formula in terms of resistivity. Remember that. Okay, now we are going to convert into the conductivity. Is it? I will start from here. Is it? So I can write here, see here, this 2 rho equivalent is equal to rho 1 plus rho 2. You know very well the resistivity and conductivity relation is the rho equal to 1 by sigma. Is it? So this rho equivalent I can write here, see 2 by sigma equivalent is equal to 1 by sigma 1 plus 1 by sigma 2. This is the main formula. This is the main formula. Okay, after that when I will simplify more, 2 by sigma equivalent is equal to take the LCM sigma 1 sigma 2, and here it will be how much here? Sigma 2 plus sigma 1. So hence students, if I will write here the equivalent conductivity, so what this will come here? 2 sigma 1 sigma 2 by sigma 1 plus sigma 2. Okay, so this one we have solved for the two conductors. Is it? Kindly see here very well. Okay, so students, here if I will check here the option, which option is matching is the equivalent conductivity? Option B is the correct answer. Which one is the correct answer? Option B is the correct answer. Okay, but remember that here if in case there is the n conductors, how many conductors are there? There is the n conductors. Okay, so see, for n conductors identical dimension, this also have to remember that. So for n conductors what will happen that here? Remember the first formula in terms of rho equivalent, it will be remember that rho 1 plus rho 2 plus dot plus rho n by n. Is it? In terms of the resistivity. Similarly, if we write in terms of the conductivity, okay, so it will become here, remember that here n by sigma equivalent, I am writing from here, is equal to what is this? 1 by sigma 1 plus 1 by sigma 2 plus dot 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 plus 1 by sigma 1. Okay, so remember that here in series combination of the conductors, this formulas we have to remember that. Okay, great. Now in case 2, because we are calculating here the equivalent resistivity, so here for parallel combination also. So see here, two metal wires of identical dimensions are connected in a parallel distance. Okay, if sigma 1 and sigma 2 are the conductivities of the metal wire respectively, okay, the effective conductivity of the combination is how much? So students, here you have to remember that here, what is this? In parallel combination we are going to do it. Okay, so see here also I have taken here the two conductors identical dimension. Okay, so see here resistivity rho 1, here resistivity is the rho 2, length how much? This length is the L. Okay, so here also one equivalent conductor having the same dimension, how much is there? Here we can write here, this is the rho equivalent, length how much, students? Here this length is the A. Okay, after that remember that here the equivalent, anyhow rho equivalent, but area of cross section, let's take this one area of cross section A, this one area of cross section A, then overall area of cross section how much here, students? 2A. Okay, so this thing we have to remember that. Okay, now for the parallel combination, remember that here we know the formula, 1 by R equivalent is equal to 1 by R1 plus 1 by R2, is it? And you know the formula, R equivalent means rho L by A. So here what we can write here, see here, rho equivalent into L by 2A. So 2A will go up in numerator. 1 by R1 how much is there, see here, rho 1 into L by A, plus due to second one, see here, rho 2 into L by A, is it? So both the sides what will cancel out? A by L all will cancel out. So students, here we can write here, see in the same way, 2 by rho equivalent is equal to how much? It is going to be 1 by rho 1 plus 1 by rho 2. Okay, 2 by rho equivalent is going to be 1 by rho 1 plus 1 by rho 2. Okay, similarly if we write in terms of the conductivity, okay, so in terms of conductivity what will be there, students? Here as we know, 2 by rho equivalent is equal to 1 by rho 1 plus how much? 1 by rho 2. Okay, so here what this will become here, 2 into sigma equivalent, sigma 1 plus sigma 2. So here sigma equivalent how much is there? Remember that here, sigma 1 plus sigma 2 by 2. Okay, can you see very well how we have done it beautifully? Is it, students, how we have done it beautifully? Okay, so if we'll see here the back side, which option is matching is there? The correct option is here option C. Is it? Can you see very well? Option C. But if we write for the n conductors of the same dimension. Okay, so see here, for n conductors in a parallel. Okay, so first one what will be there here? If we write for the resistivity, students, here this one now like this, n by rho equivalent is equal to 1 by rho 1 plus 1 by rho 2 plus dot 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 1 by rho n. And if I write here the conductivity, so what conductivity will come here, students? Just like here, I'll take the example from here. So we can write here, no, conductivity is this one here. Let me take this example, is it? So we can write here, see, sigma equivalent is equal to sigma 1 plus sigma 2 dot 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 plus sigma n by n, is it? So students, remember that here in this case we have learned for parallel combination how to deal with it for n conductors, is it? Now students, after completing here the equivalent resistivity, we will go for now equivalent resistances. Okay, so see here, equivalent resistance in different cases. So now we are going to see first one, method of same potential. Okay, so what is the method of same potential? It tells that, this remember that here, if in case this is a one wire, okay, and this is A, this is B, some part of the circuit is there, okay, and here resistance is R, and let's take current is flowing here I, is it? So what will happen that here, this is plus, this is minus. So what is the potential difference? If I will write from the KVL, I will write here, I will start with the first point, here potential VA, let's take a second sign, minus IR equal to, I will reach at point B, that means VB, that means I can write here like this here, okay. So what will happen that here, we can write here, VA minus VB is equal to IR, okay. This is the basic thing by the KVL. Okay, I hope so you have understood very well. But what happens that sometimes if in case the wire is given straight, no? This is potential VA and let's take here potential is given VB, and let's take this is the something short circuit is there, no resistance is nothing. So what happens that in this situation, in case of short circuit, resistance we will consider 0. Okay, so what will happen that here students, in this situation if the resistance is 0, what will happen that here, see, VA minus VB will be how much here, I into 0. So what we can tell here, potential of A is equal to potential of B, and this is called the method of same potential. That means if the two wires are shorted, then potential of both the wires will be, means potential of both the points will be same. Okay, this is some part of the network, some part of the network. Okay, but don't apply this thing here. Let's take here, this is A, this is B, okay, and this is directly connected to one battery. Let's take for example 10 volt battery. Then do you think that here VA is equal to VB? Do you think that here, this is a shorted here, but do you think that the VA is equal to VB? No, no, no. Why? Because now it is directly connected to the battery. Anyhow, the potential difference will create here 10 volt. Okay. So in this situation, we can't apply this. So if these 2 points are directly connected to battery, potential of A and B will be not same. Okay. So this concept we have to apply if this belongs to some part of the circuit and those 2 points are directly not connected to battery. Is it? Can you see? Very well. Okay. Great. So here we can see very well, JEE 2022 question is there, okay, JEE 2022 question is there, important for NEET also. See here, the current flowing through the given circuit will be how much here, okay, current flowing how much here, this current flowing I, okay. So here students, you can see very well, this is the belongs to the method of same potential only. See how I am going to see this here, see. I have taken this is point A and I have taken here this is point B. Okay. So what I have told you, whatever points are directly shorted, they will be having the same potential. So this is A. Okay. This is A here. See, this is all directly shorted. So here also potential how much here? A. Okay. Similarly, what I am telling here, let's take for example, as here this is B. So this is also directly shorted. Here also potential how much here? B. So if you will see students, this 9 ohm connected between A and B, this 9 ohm connected between A and B, bipolar device. No? So A, B, B does not matter here. And this 9 ohm is also connected between where? A and B. Okay. So what I will do here, if I will draw here the equivalent diagram. Okay. This is A and let's take for example B. So here we can write here, this is 9 ohm. Here also we can write here 9 ohm. Okay. They are connected in parallel. And here also students, we will write here the 9 ohm. Okay. And here what is this? This is connected to the battery. This is connected to the battery. How much is there? 6 volt. Okay. And here how much current is there? I hope so you have understood very well. Okay. So students, what will happen that here, if I calculate here the equivalent RAB. So equivalent RAB is given by, see, 9 ohm, 9 ohm, 9 ohm connected in parallel. That means it will come here, see, 9 ohm by 3. So 9 ohm by 3, what will be there? It will come here the 3 ohm. Okay. So after that students, if I will write here the current is given by V by RAB. Okay. V how much is there? 6 volt. 6 volt and equivalent resistance 3 ohm. 3 ohm. Okay. 3 ohm. This V and ohm no need to write, but okay, I'm writing here. So 6 by 3 how much is there? 2, and it will become here 2 ampere. Is it students? So kindly see very well how we have done this. 9 ohm, 9 ohm, 9 ohm connected in parallel. So it has become here 3 ohm and then 6 by 3 2 ampere. So here we have to write here the 2 ampere. Is it? Great. Now students, next one see here again this question. No, this question is there. Here also equivalent resistance of the following network how much. So here this is a very easy question, but one thing you have to remember that what is the thing here students, see, this 6 ohm is there, okay, but for this 6 ohm what is the thing you know, here if I write here the point A, for example, A no need to write because already A is there. No? Let's take, I have written here point M or potential at point M. Here also what is this? Potential at point M. Okay. So what will happen that here students here, see, this is the, this one and this one having the same potential, no? Same potential, same potential. So what will happen that here? Current will pass by this. There is the no potential difference and no current will flow in this 6 ohm resistor. You are getting what I am telling you students? Here this point M and point M, same potential, short circuit is there. So if in case any current is coming, if in case any current is coming here, if in case any current is coming here, okay, I, for example. So this current will pass by this way. This current will pass by this way. There should be not be any current across the 6 ohm resistor because easy path is available, and here potential difference across the 6 ohm resistor, how much here? 0. So current will pass through the short circuited path. Is it? I hope so you are understanding very well. So if in case I will draw here the equivalent diagram is there. Okay, this is the equivalent diagram. See, I am drawing here the equivalent diagram. This is A, this is B, and let's take here, this is 3 ohm, and students here also what is there? 3 ohm. Okay, and here what is this? This is the 2 ohm. This is 2 ohm, and here how much is there? This is 2 ohm. Okay, this is the equivalent diagram is there. Can you see very well? Which one is connected in parallel? Again, if I see this point is there, see this points. Let's take for example, this is N, this is N. So see here, this 2 ohm connected between N. This 2 ohm is also connected between N. That means this 2 ohm and this 2 ohm in a parallel. Okay, so if in case I'll draw here one more equivalent, so it will go like this. See, this is the 2 ohm. Now multiple equivalents we can draw here. Okay, 3 ohm, and here also what is this? 3 ohm. Now like this here, I'm drawing here. Is it? And this 2 ohm and this 2 ohm in a parallel. So 1 ohm is there. Okay, so see here, students, this is the 1 ohm. Okay, so after that what will happen that here, if in case again you take this point, again you take this point, let's take this point I have taken here O. Okay, so you can see very well students here, for example, if in case the current, for example, any current, for example I1 is going, so if here I1, here also I1 current will pass. Okay, very basic we are talking about. So this 2 ohm and this 1 ohm again in a series. Okay, so 2 plus 1 how much here? 3. So if I will draw here the equivalent here, what this will become here? See here, this is A, this is B. See, this is the 3 ohm, this one, again this is the 3 ohm, and this 2 plus 1, this is also 3 ohm. So now what is this? This 3 ohm, 3 ohm, 3 ohm connected in parallel. So if in case I write here the equivalent, it is given by 3, 3, 3 connected in parallel means 3 by 3. Answer how much is there? 1 ohm. Okay, can you see very well how we have done this 1 ohm? So here what will come here, students? Here it will come here the 1 ohm. Oh, that's why method of same potential is the very important. Okay, great. Now students, in case 2 we are going to see here the balanced Wheatstone Bridge method. Okay, so what is this? See, it consists of 5 resistors as shown in a circuit diagram, and in balanced bridge resistance R5 will not allow any current, so it can be removed here. Okay, so all these stories we have seen, but how the Wheatstone Bridge looks like. Okay, so see here, this is the Wheatstone Bridge actually. Now this is the Wheatstone Bridge. See, I'm drawing for you. Now like this. This is the Wheatstone Bridge. Okay, and let's take here, I have written here. This is R1, this is R2, this is R3, this is R4. Later we will see in a detail also, but as of now we are learning the equivalent, so we are doing here. And let's take here, this is the R5. Okay, so what will happen that here, students, if I write here the potential, this is point C and this is point D. So what happens that for the balanced Wheatstone Bridge, balanced Wheatstone Bridge. Okay, so here what will be there? See here, this R1 by R2, R1 by R2 will be equal to R3 by R4. Okay, R1 by R2 is equal to R3 by R4. Even if you wish, you can write here R1 by R3 is equal to R2 by R4. Okay, so you know in this situation, students, what will happen that here? In this situation, potential at point C, that means this potential will be equal to potential at point T, that means this potential. So what will happen that here? As there is the no potential difference for resistance R5, it will not allow any current. Okay, it will not allow any current. Current in the R5 will be 0, so it can be removed. Okay, so this thing you have to kindly remember that here. Now, so this thing you have to remember that. Multiple ways are there to represent the Wheatstone Bridge. Okay, that we will see one by one. So kindly see the students very well how we have done here the Wheatstone Bridge. Balanced Wheatstone Bridge means the potential at point C and potential at point D is the same. Okay, now let's see here. This is also one form of Wheatstone Bridge. Okay, Wheatstone Bridge can be looking like this also. Okay, so see here, please students, what is this? The current I in the given circuit will be how much? Now, how I can tell this is the Wheatstone Bridge? Let me write here. See, this is also Wheatstone Bridge. So see here, please. I have taken here, let's take for example, this is A, this is B. No, just 1 minute. Let's take this is the B, and students, let's take here. This I have taken C, and this I have taken here D. Okay, so students, if I write here, can you see it? I just draw here the Wheatstone Bridge, then you can see very well what I am going to do here. Okay, and I am just going to put here the things. This is A, this is B. Okay, and students, let's take here, this is C and this is D. This 2 ohm is connected between C and D. This is the 2 ohm. Okay, and after that you can see here, students, here this 4 ohm is connected between A and C, so here 4 ohm. After that again this 4 ohm connected between A and D, so here also 4 ohm. Okay, and after that what is this? This 4 ohm is connected between C and B. Are you seeing it here? And this 4 ohm is connected between D and B. Okay, so see here. Now you can see very well, students, this is also what is this? Wheatstone Bridge. Wheatstone Bridge we can draw like a this also. So you can see very well this 4 ohm and this 4 ohm, 4 by 4, 1. Again 4 by 4 1, that means this is the balanced Wheatstone bridge, okay, and we can remove this resistance. So the moment we will remove this resistance, you know what will happen at here? If I will calculate here the resistance across point RAB, okay, so see here, the moment this 2 ohm will be removed, what will happen? This 4 ohm and this 4 ohm will come in series 8 ohm, and this 4 ohm also come in series 8 ohm, then 8 ohm and 8 ohm in a parallel. So when 8 and 8 in parallel, how much is coming is there? 4 ohm. Now, this thing we have got here. After that, what we have to calculate here? The current. Now, so students, if I write here the current, I is equal to, we know very well, the equivalent between A and B, we have got here how much? We have got here 4 ohm, and here battery is connected 40 volt battery. How much battery? 40 volt battery. Answer 10 ampere. How we can tell students 4 amperes here? 10 ampere. So see, 40 by 4, how much is coming? 10 ampere. Okay, which option is matching is there? Can you see very well? Option is A. Now, so in this way also balanced Wheatstone bridge can be written. Okay, great. Now students, see next one. This is the also JEE 2021 question is there. Okay, so see here, 5 equal resistors are connected in a network as shown in figure. The net resistance between the points A and B is how much? Okay, here A and B is given. This is also Wheatstone bridge. Okay, how can I tell here? See here, students. If I write here, see, this is the R. Okay, and this I have taken here, okay, this I have taken here B. Now this B I have extended that side, this A I will take it this side. Okay, so see here, this one, and this is also students, so you can see very well, and here students I can write here, see, this is the A, and anyhow this is the B, this is R, this is R. So can you see very well students, this is also Wheatstone bridge. Why? Because this A I have taken and I have taken this side and it has become this. So if in case this is the potential VC, and if in case here potential VD, so R by R 1, again R by R 1. So what will happen students? This resistance can be removed. Okay, so from here we can tell students, you can see very well, this R and this R in series 2R, this R and this R also in series 2R, 2R and 2R in parallel. So RAB will become here 2R by 2, how much here? R. So remember that in case of Wheatstone bridge, if all the resistances are R, equivalent is also going to come R. Similarly, if all the resistances are 10 ohm, equivalent is going to be how much students here? 10 ohm. Which option is correct is there? You can see very well. The correct option is here, option D. Okay, great. Next one, see students here, the question. Case 3 actually, the case 3 is there. See here, the symmetry method. So here you can see very well students, see. If we draw a line perpendicular to symmetry line, then all the junctions on this line will be at same potential as shown in diagram. Okay, so for that students, I will draw here the one diagram. Okay, so for the diagram, just let me draw here this. Just I have taken like this. Okay, can you see very well? And here students, I am just taking here, see, this resistance is there, like this. I am drawing here the resistances. Okay, like this is there, and here also students, resistance. Now see here how I am doing here. This all the places, what is this? Resistance is there. Okay, and what are the all values? Let's take here R, this all are R. Now let me write here. Now, so if in case students, if you will apply here any basic, nothing will work out, no? Because no series, no parallel like this is there. Now maybe you may think here this R and R in series, but after that you will stick. So you know here what we have to do. Here we have to apply here the symmetry. How we can apply the symmetry? If we have to calculate here the equivalent between point A and B, then students, what will happen that here, remember that here, this line, which line I am talking about here, let me draw here, see this line, okay, this line is called here, which line students here, this is called here the symmetry line, this one is talking about symmetry line. Okay, and what will happen that here students, if I will draw here any perpendicular line, this is the perpendicular line I am drawing is there. Okay, this is the perpendicular line here. Okay, perpendicular line here. Okay, because this is symmetrical line, this is which line? Perpendicular line. Then what will be there? All the junctions on this line will be at which potential students? Same potential. Okay, so you know what will happen here students, if I talk about here, if we talk about here, okay, and if in case I give here the name, okay, so let's take here for example, this is VA, this is VB, and let's take here the students VC. So you know what will be there? All this will be at same potential. Okay, VA equal to VB is equal to VC. Whatever junctions will be there on the perpendicular line, they will be at which potential? Same potential. Okay, so what will happen that here, if potential of A and B is same, this resistance can be removed. B and C is same, this resistance can be also removed. Okay, so students, when we'll remove here the resistance, then you know what will happen at here. See here. Here you can see very well, this is A, this is B. Now this R and this R will come in series 2R. Okay, and after that, see here, this R, this R, this R, this R all in series. How much it will come here? See, this one will come here, the students, here 4R. Okay, and here also R, 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 they will also come here. How much here, students, here 4R. Is it? Now you can see very well, students, here. I hope so you have understood very well. This 4R and this 4R in parallel. So 4R, 4R in parallel, 4R by 2, 2R. Okay. So if in case I'll draw here the equivalent, it will come like this here. See, this is the 2R. This is always there, and 4R, 4R equivalent. How much is, students, here? This is the 2R. Okay. And here AB. Now this 2R and this 2R in parallel. Is it? So students, if I write here the equivalent, this RAB will come here. This 2R by 2. This 2R by 2, what will come here, students? It will come here R. Is it? I hope so, because this kind of questions can be solved by this way only. I hope so you have understood this thing very well. Okay, students? So now we are going to see under the case 4. Case 4, what is this? Infinite ladder method. And this infinite ladder method we are going to learn with the question. So see here. NEET 2022 question is there, and students, this is important for anyhow JEE also. Okay, for JEE also important. Is it? So see here, the equivalent resistance of the infinite network given below is how much, and this kind of circuit is given. Okay, students. So remember that here one thing, in case of infinite ladder method based question, we should search some kind of symmetry. So see here, if I will see the circuit from here A and B, and let's take here the students, here equivalent is X. Okay. So similarly, if I see the circuit from here A and B, okay. So you know very well, students, here also equivalent will be how much, you know, here also equivalent will be X only, because see, if you see from A and B, it is looking like this. If you hide this much portion, then you can see from A and B again the same kind of circuit is there. Okay, students. So remember that here, if the equivalent between A and B is the X, here also across A and B it will be how much here? X. So if in case I will draw here the equivalent, okay, so see here equivalent I am drawing here. This is the equivalent here, students. This is A, this is B, this is 1 ohm, 1 ohm, 1 ohm. And here also, what is this here, students? Here, this is point A, and this is point B. How much equivalent? X, because here X across this AB, X, then across this AB also X. I hope so you have understood very well. Now we have just removed one branch here, and we can see from this AB also same kind of circuit is there. Okay. So now, students, after that, if I write here the equation. So here you can see very well, students, here this 1 and X in a parallel. So when 1 and X in a parallel, we have to use the formula R1 R2 by R1 plus R2. Okay. So this X is given by here, please, here. This is 1 plus this one in a parallel. So we can write here X into 1 by X plus 1. So X by X plus 1. Okay. Is it? And this plus 1 again is there. Now, so we have to simplify this here. See kindly, X equal to 1 plus 1 2 plus X by X plus 1. Now, so students, I will take here the some LCM and all. This X plus 1 multiply here. So it will come here 2X plus 2 and here plus X. Now, can you see very well? We hope so we are going very correct only. Is it? Because mistakes should not happen. So from here, students, we can write here X into X plus 1. Now, see, I am writing here. Now, this X into X plus 1 is equal to what we can write here, students. This X into X plus 1 here 2X plus X, 3X plus 2. What will be there, students? 3X plus 2. Is it? So it will become here, see, X square plus X is equal to how much? 3X plus 2. Again, kindly simplify this. X square, this will come this side, minus 3X plus X minus 2X plus 2 equal to 0. Okay. This is the standard equation. I hope so we have done the perfect calculations. Okay. So students, if we want to write here the solutions, two solutions are possible, but from the Sridharacharya method, we can use here, see, minus B plus minus square root of B square minus 4AC by 2A. How we are getting here? Because we have to compare with this one here, AX square plus BX plus C equal to 0. Okay. So if you will see very well here, students, see, I will write here minus B value how much here? This is B, here minus 2. So B value is the minus 2. Is it? Plus minus here square root of B square. B value how much here? Minus 2. So see here minus 2 square minus 4. A value, this is A, and here A value is the 1. Okay. And C value how much is there here? See, this is C, and here C value is how much here, these students here? This is the C value is the 2. Okay. Can you see very well how we have done here? Going correct, huh? One mistake has happened. because here imaginary root is coming. Okay, this should be the minus 2. See here, this plus 2 will come this side now, minus 2. Okay, so see here, minus 2 by 2a. So 2 into a value, how much here? 1. Is it? So now we have to simplify this here, students. Let me write here. The simplified value is there. Okay, so 2 plus minus, this one will come, how much is there? 4 into 2, 8. And 8 plus 4, 12. Okay, so root 12 by 2. Okay, so 2 plus minus, we can write here 2 root 3 by 2. Getting? Because root 12 means we can write 2 root 3. Okay, so when we will simplify this x value will come here 1 plus minus root 3. Okay, and students, remember that here root 3 value is the 1.732 and resistance cannot be negative. Okay, so what will happen that here, if I write here the root, the first one is going to be 1 plus root 3, second one is going to be the 1 minus root 3, and you know very well the resistance cannot be negative. So this is going to be the answer. This cannot be the answer here. Okay, so you can see very well, students, the which option is correct here. You can see very well the correct option is here, this one here, 1 plus root 3 ohm is the answer. I hope so this infinite ladder method you have understood very well. Okay, now students, this cubical arrangement of resistors is there. Here what is this? Let's take 4 wires are there, each of them are having the same resistance like R, 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 R. Okay, so here what will happen that here, students, if we'll see one by one, if I write here the body diagonal, where if I want to see the resistance across the body diagonal, you know very well, students, where is the body diagonal? This 1 and this 4 is the body diagonal. If in case this side, for example, if in case this side L, then body diagonal will be L root 3, is it? So body diagonal. So across body diagonal, remember that here, this resistance will come here, R14 equal to, remember that here, 5R by 6. Okay, have to remember that. Next one is, students, if we see here the phase diagonal. Like this only I used to remember that. Okay, so phase diagonal, which are the phase diagonals? Can you see here? This 1 and 3 is the phase diagonal. Okay, students, so remember that here, for this phase diagonal R13, this is going to be how much? Remember that here, 3R by 4. Okay, and if in case I see sidewise, which one is, students, here? Sidewise. Sidewise means where it is there? This 1 and 2. So remember that here, this 1 and 2, this one is going to be the 7R by 12. Okay, maximum to maximum cases, this is the only things. Please remember that here, you can cross check also, but from my point of view, I think so, I have written the perfectly correct. Okay, and remember that here, one more thing, students, if in case this is the capacitor, what is this? Instead of resistors, what is this? Capacitor is there. So situation will be somewhat changed, like C14 is going to be it will be 6C by 5. Okay, this thing. And after that, if I write here, let's take for example here C13. So C13, just reverse, it will become here 4C by 3. Okay, 4C by 3. And if in case we have to write here the C12, it will become 12C by 7. 12C by 7. So if in case resistor is there, this left side formula you have to use. If in case capacitor is there, that right side formulas you have to use. So I hope so, students, this all the things you have understood very well. Keep studying, keep growing.